Today we're going to be looking at the Pythagorean Theorem and its converse. So with the Pythagorean Theorem, in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse, meaning a squared plus b squared equals c squared. So if we take the lengths of our legs and square them, and we add these two together, they're going to equal the hypotenuse squared. The Pythagorean triple is a set of non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. The converse of the Pythagorean theorem is if the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So let's look at our first example problem. So Leslie used the diagram to compute the distance from Ferris to Dunlap to Butte. So in this case, when she traveled from Ferris to Dunlap to Butte, she went 123 miles. How much shorter would the distance have been if she went straight from Ferris to Butte? So here we're looking at, this is going to be our hypotenuse. So this is our c squared. So since this is our hypotenuse, we know that if we take 60 and 63 and square them, we need to add them together. So 60 squared plus 63 squared will equal our hypotenuse squared. So 60 squared, we end up with 3,600, plus 63 squared is 3,969. So if we add the two together, it's 7,569 equals c squared. So we know the area of the hypotenuse, but now we need to square root both sides so we know what the length is. So if we square root our answer, 87 miles. So this is 87 miles. But we want to know how much shorter it is to go from Ferris to Butte than going from Ferris to Dunlap to Butte. So if we take our 123 miles and subtract 87, we find that it's 36 miles shorter. Now let's find the length of the leg of the right triangle. We are not going to be working in radical form yet, so we're just going to find the length of the triangle, we'll round it to the nearest hundredth. So here, this is going to be our hypotenuse. So we need to take our two shorter sides, which is 21, and square it, add it to our other short side, which is a squared, and set it equal to the hypotenuse squared. So 21 squared is 441. We don't know what a squared is. And then 27 squared, 729. So to solve for a, we're going to subtract 441 from 729. So a squared equals 288. Square root both sides. So if we square root 288, if we round it, it's going to be 16 and 97 hundredths. So that's going to be the height of this right triangle. Theorem 8.3, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides of the triangle, it is obtuse. So what we need to make sure we know is that when we take the hypotenuse and we square it, and if it's greater than a squared plus b squared, then it's going to be obtuse. So meaning if this is our a, b, and c, if we take and square a and square b and we add these two together, and it's smaller than this one squared, it's obtuse. 8.2, we don't need this, it's already written there. 8.3 states if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, the triangle is acute. So this is what we're working with. So it's saying that if our length c squared is less than a squared and b squared added together, it's going to be acute. So a, b, c. So if when we square a and b and we add them together and it's greater than this third side squared, it's going to be an acute triangle. So we're working with acute and obtuse. If you find three side lengths that form a right triangle and decrease the length of the longest of them, what type of triangle must be formed? So what we're saying is we have our right triangle, and we take these lengths and we decrease the length of the longest. So our longest is our hypotenuse, and if we decrease it, that means when we add a squared and b squared together, it's going to be greater than c. So we're going to have an acute triangle because c squared is going to be less than these two added together. So we want to figure out which triangle could have side lengths 11, 60, and 61. So is it going to be acute, obtuse, or right? So we're going to take the two smaller sides, which is 11 and 60, add them together once we square them, and we're going to see if it's equal to 61 squared, if it's greater than or less than. So 11 squared is 121. When we square 60, we end up with 3,600. And 61 squared is 3,721. So if we add 121 plus our 3,600, we end up with 3,721. Since they equal each other, this is a right triangle. So let's look at this next one. Take 4 squared, add it to 6 squared, and see if it's equal to 7 squared or if it's greater than or less than. So 4 squared is 16, 6 squared is 36, 7 squared is 49. So our next step would be, what's 16 plus 36? 52, and we know 52 is greater than 49. And since this is the hypotenuse, and 49 is less than, this is going to be an acute triangle because the hypotenuse is less than the two shorter sides added together.